We're going to start off with the basics and we're going to start off with something called measurement. In particular, we're going to start off with numbers and units. This is very, very important in physics because physics is using maths, it's using numbers. And so we need to be confident with how to manipulate those numbers. In order to do it, we need to understand prefixes, we need to understand standard form. So before we begin, let's just make sure you're happy with standard form. If I write a number like this, now you'll notice that I put in these commas, and that's because it makes it a lot easier to see what the number is compared to if I just did this. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can see I had to stop to count the number of zeros, whereas here I know that each one is grouped in threes. And so I know there are 3 groups of 3, so 9 zeros. However, even doing something like that is very, one, it's time consuming, and two, you can easily make a mistake. So we use something called standard form, and standard form means that we turn this into 1 times 10 to the power of 9. This means that we don't have to count the number of zeros, and when we type it into our calculator, it's a lot easier to type and use. And it's not just with large numbers, we can do it with small numbers. So same thing, if I have this, 8. So if I have this number, again, rather than trying to count the number of zeros or typing this into your calculator where you're where you're more likely to make a mistake because of time pressure and stress of an exam, we can write this as 8 times 10 to the power of minus 3, 6, 9, 10. 8 times 10 to the power of minus 10. Again, less likely to make a mistake, easier to type in your calculator, less time consuming. So do make sure you come to a standard form before you continue. If you do need help, do feel free to comment, email, let us know. Let's jump straight into this. So prefixes, what are they? Well, you actually use them in your everyday life without yourself realizing. Words like kilometer, kilogram, centimeter, those are all examples of prefixes being used. You might even use terms like gigabyte, terabyte, if you're talking about computers and storage. At least that's what comes to my mind. So the words giga, tera, centi, kilo, those are all prefixes. They all actually put a slightly different value to the number we're saying. So we need to, in physics, we need to make sure that you are comfortable with what those prefixes are and what number those words represent. So we're going to put this in table format. We're going to make sure, well, we need to make sure you know what the name is, what the symbol is, and then what the multiplier is. And hopefully this will make things a lot clearer. I would suggest you keep this down as reference to make it easier to use as you go through the course. Let's start off with one of the larger values you are probably going to need, and we'll start off with tera. Tera has the symbol capital T, and its multiplier is times 10 to the power of 12. Then we have giga, which has the symbol capital G and the symbol and multiplier 10 to the 9. Then we have mega. Mega is a capital M. Now, the cases are actually very, very important in this, and you will see the importance of it as we go through the different multipliers. This is 10 to the 6. Kilo is lowercase k, which is 10 to the 3. Now, the next ones, I'm going to actually put a separate line in orange, and I'll explain why after I finish the table. We have deci, which is a lowercase d, 10 to the minus 1. We have centi, lowercase c, 10 to the minus 2. And that was another orange line. Before then, we continue. we have milli, which is lowercase m, 10 to the minus 3. Micro, now micro has a Greek symbol mu, which is written like this, 10 to the minus 6. Just two more. After micro goes nano, which is a lowercase n, 10 to the minus 9, followed by pico, lowercase p, 10 to the minus 12. Now, if you look carefully at this table, again, I was saying how it's very, very important that we know that with the cases. And that's because if you look here, we've got a capital M and a lowercase m. And if you get the case wrong, you can see you then end up getting the completely wrong, change colour here, multiplier. So very, very important that we use the correct casing here. Now, let's see if we can understand why I put deci and centi in between yellow, orange lines even. If you notice the multipliers, can you see how they're all in multiples of 3? Well, physics likes to stick to this pattern, okay, where everything is in multiples of 3 to make it a lot easier for us to determine. And this is why also when we write numbers, we put the zeros in multiples of 3. It makes it a lot easier to determine what the multiplier, what the symbol needs to be. You'll notice on deci and centi, we don't have that. Now, the reason why we still use deci and centi is because we actually, it's more convenient for us in our everyday lives. Centimeter, right? We use that a lot for measurement. Deci, not so much. If you might have seen it on bottles where it's like deciliter, but we use those more in our everyday lives. We're less likely to use milli and kilo. So they actually introduced these just to make it easier for us. They are still terms that are used, but we don't tend to use them in physics. We tend to stick with the ones that are multiples of 3, so the ones that are highlighted in green. So how do we put these prefixes to use? So let's have an example. Let's say I've got a number 2.59 millimeters. The question is, what number does this actually represent? We have the standard units, meters, and we need to get rid of that prefix, milli. Well, this milli here actually means times 10 to the power of 3 according to our table. And so this becomes 2.59 times 10 to the power of 3 meters. Another example, let's say we have 3.68 gigawatts. Again, this giga means times 10 to the power of 9. And so this number, 3.68 gigawatts, is 3.68 times 10 to the power of 9 watts. This is trying to get rid of the prefix. What if we are trying to use the prefix? So let's say we've got the number 39,800,000 meters. Again, we don't like the idea of having so many zeros, and so we want to use the prefix. Well, we know that they go in multiples of 3, and I've conveniently written them so that I have split the number so that I've got multiples of 3. So I'm going to get rid of here, which is 6. So actually, this number is 39.8 times 10 to the power of 6 meters. Now the prefix for 10 to the minus 6 is mega. So my answer becomes 39.8 megameters. Another example, let's use 0.000000321 hertz. Here I've got 3, 6, 7. Right? In order to write this in proper standard form, this actually becomes 3.21 times 10 to the power of minus 7 hertz. Now we don't have 10 to the minus 7 as one of the prefixes, and so we're going to change it so it becomes 3.21 times 10 to the power of minus 1 times 10 to the power of minus 6 hertz. Reason being, because this is the same as this. And so using this new prefix, I end up getting 0.321 micro hertz. Another way of doing this is actually making it even smaller. So I could potentially change it so it becomes, so instead of having 0. So here, let's rewrite the number. Instead of using 7, I'm going to change it so it goes 1, 2, 3, 4, 5, 6, 7, 8, 9. So actually this becomes 3.21 times 10 to the power of minus 9 hertz. And I know 10 to the minus 9 is nano, so it's 321 nanohertz. Let's try and put what we've just learnt to use. Have a go at these questions. These questions are from the Oxford edition of the physics iGCSE textbook. Have a go at these questions and I'll go through the answers in the next video.